Yeah, all right. I'm in the University of I'm recording system for the lecture. So
is this unmuted?
No. Just trying to make sure sound is going.
I don't know about the video.
Video should be fine. They said they could see that.
Okay.
Well, let's get started. Thank you for being here today. So it's my honor and pleasure to introduce Rodrigo, and she's gonna say the same with me. So we are here to talk about what we've been doing over the last months that connects us with work that I had started some time ago on the issue of using visualization technology to support decision-making in a business environment. And the type of object that we are using is a data set where the information is coming from, particular data set, which will be explained. So the way this is going to unfold is I'll be introducing most of the issues around, because there's like 3 or 4 things coming together. And then Ruhi will be talking about the specific experiments and the results. Now, what is our expectation? Well, we would like to listen to your ideas and thoughts or reactions to what you hear today. So we're not going to spend a lot of time. We'll try to keep our participation to the minimum. And then let me just tell you what this is, how this is going to unfold. So just sit there and when it's your turn, we'll switch places. Okay. I can just manage this one. Yeah. All right. So there's some people on Zoom, and if you have any questions, just speak up or just use the chat. We'll be watching for that. So this is going to go like this. Well, an overview of the problem we study, and followed by what is immersive analytics, by the way, which is like the area that connects us in the more theoretical things. And we had to build a virtual reality environment, not necessarily for the purpose of this research that we had already built it. So we've been refining and making this environment better, and it's accessible here at in one of the rooms on the 5th floor of this building, and we call it Auto Lab. And then I'll go into the specifics of the problem we are studying, introduce some technical jargon, and then we'll switch to the other presenter, the nicer presenter, and she will be talking about the experiments and the results, and followed by a discussion. So I want to reiterate the invitation to help us with your comments or anything any reaction this presentation may have on you. So the problem, I'm going to state it in 2 parts. And the first one is saying that we're going to use a immersive technology, mixed reality immersive technology. So devices that you can wear on your head, and that where you can watch stuff. In particular, visualize data, and we believe that's going to support like more effective and higher quality decision making in a business context, using a particular kind of a data format or data set, database actually, which is known in the market as graph data, a graph database, which is basically allowing us to deal with a network data set. And in a sense, this will be more clear hopefully for you a little bit later. And what we want to do is to have 2 technologies for visualizing that kind of data. One is the mixed reality immersive technology. The other one is using a flat screen, like a computer screen, with another type of visualizer on a more like a 2D kind of presentation and compare. That's what we want to do. One of the issues is how we define how we define the quality of the decisions to make. So all these things hopefully will be more clear as we progress. Now, immersive analytics is a rather new field, and has been pushing its way into the data analytics area or field, building upon these elements: data visualization, visual analytics, virtual reality in particular, also augmented reality in some sense, computer graphics, and the interaction between human and technology to support our understanding of data. And this is for either individual or collaborative decision making. So that's the ultimate purpose. We are using VR headsets and appealing to the participant senses to get to where we want. We are not going beyond that kind of experience, like more sensorial kind of experiences that immersive analytics would also have for interaction with technology. We built the Arrow software, and this is as far as I'm going to go in terms of the technology. It's an integration of different things that we use software that gamers use, game developers use, as Unity. It's very popular. We use Microsoft Mixed Reality Toolkit to provide client services. And we use other pieces of software like Photon that allows us to have coordination among participants and the server, and Microsoft Azure Cognitive Services for a particular feature there, which is speech-to-text conversion. In this environment, we can leave messages, voice messages, and they will be converted to text, just especially for the developers to take and see what the problems are being reported by users. 25 and Heroku, that's a way for us to do math calculations that we need to do outside the main client there. So that's, as you see, it's an integration, several pieces, and it's been working quite well, obviously with some issues sometimes that we need to take care of. So coming back to the problem we studied. So yes, we use a mixed reality immersive technology and the other technology as well, the flat to the screen. For what? Well, it turns out that these decision makers will make decisions about who's the most important node among all the nodes in a given network. The network is being represented by a network data set, a particular structure that has been explored really in a rich way in the last probably 6-7 years. The popularity of graph databases, which are the databases that we are using for the network data set, for representation of networks or network information. The popularity has been growing and declining a little bit over the last 2 years, but it remains strong as a new member of all these different databases, and being relational databases being the most popular by far. But graph databases are finding its way because of the importance of network structures and network information for analysis in different organizational settings. And we're going to do it in a way that these decision makers are going to be facing immersed virtual, are going to be immersed in a virtual environment, or alternatively and in a comparatively way with the flat screen technology, more traditional way of representation. So in the end, we want to see these two things happening for us. Is it more effective one way or the other? And but what do we use? What criterion we use to say that is more effective? So let me get technical for 2 minutes, because the main concept here when we approach this problem is called network centrality. So what is network centrality? So let me just walk you through the construct, and in order to get there, we are assuming we have information about a social network. Well, those are very popular. They have been growing like crazy over the last 10, 15 years. We do belong to different social networks, internet-based, of course, and we're talking here, online. And as you may have realized, this is about people connecting to other people. Oh, it could be companies connecting to other companies and so on. But let's say that we're going to understand those people or those organizations as nodes of a network, and the relations will be links. It's a simple idea of a graph being used for different purposes, mainly for connecting people to people. So we believe, given evidence out there in the market, that this may be relevant to different organizations, among them, for instance, marketing agencies or market research companies that need to analyze the behavior of people in a social network context, so that we, in the end, we end up with a very simple structure that is made up of nodes, be a person, and links. And the links is a relation between two of those nodes, and it's bidirectional. So if I'm your friend, you're my friend. So we're not talking about here social networks where we have followers and that kind of thing. We're just on the bidirectional mode. And we are going to use 3 ways to understand the importance of a node, which are based on the concept of centrality. Now, there are 3 types of mainly. There's a 4th one we're not using, which is also important in this context. We are using these 3 that I'll be talking about in the next minute. The first one is the degree centrality. Basically, given that we know that we're dealing with a graph, we're talking about the degree of a node. That means how many friends or how many connections a node has. That's degree centrality. Is probably easier to understand, and that may represent the influence of a person on the network. But over time, other concepts were developed, and one of them is closeness. Closeness centrality is talking about the how my position in a network is allowing me to spread news more quickly. So in a way, we are interested in that kind of effect. How a person in a network would be important if its position there would allow the spread of the message more quickly. And the technical definition we are not dealing with here in this presentation, but is basically using the concept of shortest paths. So in a way, the way to shortest path in a network, which is of course the path that connects any 2 nodes with the least number of links among the 2, 3, or many that would connect those 2. So when we ask ourselves, what is the node that is closer to all other nodes in the network, we have to appeal to shortest paths. And there's a technical definition that would give us a number between 0 and 1, the normalized number, and the higher the number or the closer to 1, that would be a person that we would consider the most important. There's another concept that is betweenness centrality, is based on also the position of a person as being a person that sits on most shortest paths between other two nodes. Of course, that is translated into a formula, and also the formula is a normalization of some values. So you get the number between 0 and 1, and the closer to 1, the higher the betweenness. So there you go. You have three concepts there, numerical concepts anyway, or represented by quantities. And the thing is that if all of them would determine that a node is the highest for each one of those, well, that would be the most important node in the network, and that's the end of it. It turns out that these three may give us ambiguous results. Sometimes betweenness is higher for one node and closeness is highest for another one. So how can we determine who is the most important person in the network when we have criteria that are producing some ambiguity? That's the challenge here. Obviously, this centrality thing is going to depend on the context, and sometimes we have to combine two or three, all three, to arrive to some kind of decision. Decisions in this context are, we are going to contact that person that we believe is the most important, extend probably a contract for that person to become an influencer in the network on our behalf. That's the kind of thing. Now we bring our volunteers, or we call for volunteers to experiments, and we explain this to them. This is probably the driest, hardest part to do during the experiment. They have been very kind and supportive, by the way, and we walk them through some concepts, through those concepts, using a simple example and trying to get a flavor of the analytics there, the formulas, without going into too much hassle, and reiterating the difference between the three concepts. At the end of which, we are basically ready to, at the end of which, well, they will be helping us in the lab. So what is it that we've done to reach our objectives in this research? Well, let me just say again, we built that RO tool as a mixed reality multi-user platform. We also use a commercial tool, Giphy. It's a network visualization tool. It's not a graph database. It's a network visualization tool. We created a fictitious social network data set, and we asked the question, who is the most important node in the network? Conducted experiments, asking subjects 6 questions each in each of the two platforms. We call them platforms, visualization tools, and collecting the data. This is a picture of what people see inside those headsets, in particular in the using our RO tool. And I didn't make a video. Probably was going to take some time here, so I decided not to present a video, just to show you this. Most of people sitting here today have used the RO. At least I can see some faces here. You came to the lab, and you're more than welcome to come to our lab, room 587, here in the building, and enjoy our RO. Not only for this, but we have other uses of visualization, data visualization, plus other two tools where we apply this technology. So this is what we are, the way that we want to enunciate what we want to investigate. Immersive visualization tools facilitate higher quality decision making compared to 2D flat screen visualization tools. Well, you can see the flavor there. We believe that the tool that we are designing and have designed and tested and used now is better than the other option for the purposes of making the kind of decisions that I explained. with the visualization engines. And being the end of it for me, and now I give the floor to Ruby, who will be talking about the experiments. Thank you.
Thank you, Fernando, for walking us through our whole experiments, the problem that we are studying. And now I'll continue from this end, and I'll be focusing more on what type of experiments we conducted, how we conducted those experiments, what data we collected, how we analyzed that data, and I'll present some results, and then we'll open the floor for discussions and Q&A. All right, so just to give you a brief idea about the experiment design, we conducted these experiments in 2 stages. Total, there were 30 participants who participated in this. And like I said, in hypothesis, you saw that we are comparing the decisions, the quality of the decisions made by participants on 2 platforms. One is RORO and one is GEFI. Now, how we are testing or how we are measuring the quality of responses, I'll talk about that in a minute. To avoid or to reduce the effect bias, the participants were assigned in 2 groups, whether to answer questions on RORO first, or some participated and answered the questions on GEFI first. So it was random allocation of participants, which platform they are using first, basically. Overall, there were 12 questions, 6 for RORO, 6 for GEFI. Now, 3 questions on both platforms were expected to be having or to require low cognition or low cognitive effort from participants. And 3 questions on both platforms, again, we are expecting that they require high cognitive effort from the participants. And like Fernando mentioned, that for this case study, we considered a fictitious marketing campaign with access to this network data set. And data is from some social media company. You can think about some social network or social media company where we have 2 types of nodes. One are influencer, one type is influencer node, and the second one is personal users or individual users. Now, one more point I would like to make here is the questions, although we have 6 questions on each platform, there is no one-to-one mapping that, okay, question number 1 is exactly the same as question number 1 on GEFI and on RORO. So we shuffled the questions on both platforms. And second thing, they are not necessarily the same questions on both platforms. Some are exactly same, but others are comparable, you can say, in terms of cognitive effort that is expected, that they will require. So that was about 6 questions on each platform. Now, subject training. We started the experiment by explaining the concepts of network centrality, degree, closeness, and betweenness to the participants. And then we were training the participants to how to use this RORO headsets. And on these headsets, maybe they don't have any prior experience. So some training was given to all the participants on that. And then we gave them some time to get used to the VR headset in case they require that. And once the first step of this experiment is done, where the training is given, they are used to the platform, then on these 2 platforms, one is RORO and on GEFI, we presented them 6 questions each. Now, what do these questions indicate? These questions are basically indicating the decisions that they make for running this marketing campaign. Let's say the company is promoting some products, and to promote or to advertise these products on social networks, they are making use of some important nodes on this social network. Now, those important nodes can be influencers, it can be personal users, but yeah, the end goal is to promote their products. So that was the experiment design. Yeah, and just to walk you through some questions that we presented in RORO and on GEFI. Like I said, the questions not necessarily they were exactly the same, but as you can see, the first question on RORO is who is the most connected personal user and why, which is exactly the same on GEFI. And Now, to answer this question, participants will have to think which network centrality measurement they have to consider to find out which node is the most important to answer this question. Now, this question, since it talks about the most connected personal user, obviously they have to look for degree centrality, because degree centrality talks about the number of connections the node has, and the node with highest degree possibly is the answer to this question. And like this, these 6 questions were presented to them on RORO, and similarly, 6 questions on GEFI. I'll just focus on the 2 ones. First one I already talked about. Let's talk about question number 4. On RORO, as you can see, this question is more about asking them to choose between amongst these 3 personal nodes. I'll just read this part of this question to give you some context. So you are working for the marketing and sales department in the startup fashion company X. Your manager wants to invite 4 users to try the latest product and post feedback on the platform to let as many other potential customers know about their experience and benefits of the product as soon as possible. Now, he has already chosen 3 customers, and these are personal users, 28, 47, and 50. These are the node numbers, and wants to choose the 4th one amongst the 3, 36, 41, and 33. He would like to count on your advice who should be the next one. Obviously, here the answer should be one of these 3 options, 36, 41, and 33. And these should be, and these are personal users and not influencers. Now, a similar question with similar cognitive effort is this on GEFI, but this question is asking for the influencer node. And again, we are giving 3 options to choose from: 54, 22, and 55, and the participant is expected to choose one of these, considering those centrality measurements, degrees, closeness, and betweenness, and whichever is relevant in this context. And like you see, these are not same questions, but these are with similar cognitive effort. Now, first 3 questions on each platform are in the category of low cognitive effort, and the last 3 are with high cognitive effort, relatively. Now, because we had shuffled the questions and for our analysis and comparison, we need to know that what is the mapping or the matching pairs when we are doing the data analysis. And here is the mapping. So D1 to D7, 1 to 6 are questions for D1 to D6 are questions for RORO, and D7 to D12 are questions for GEFI. But because they are shuffled, this is the mapping that we used. Now, to just give you some idea about how we conducted the experiments, like I said before, first, we explained the concepts of network centrality. You can see Fernando here explaining the participants, and you're happy to see that some of the participants are present here as well today for this seminar. So we explained these concepts to them first. And what you can see is our RORO lab, our own research space on level 5. And then we trained the volunteers or the participants on RORO operations and also how GEFI works. You can see me here in our research space demonstrating how these both tools work. And then what you're seeing here is the tech hub on level 1. And basically, this is giving them some practice to work on the headsets in case they don't have any prior experience. And finally, they use both platforms. On the left-hand side, what you are seeing is they are using the GEFI 2D flat screen tool. And on the right-hand side, what you're seeing is they are using RORO on VR or mixed reality headset. And they are answering 6 questions on each. Now, I'll not go through each and every question and the results of this, but I'll just spend a couple of minutes on 2 questions that I highlighted. Let's see the results for the first question, which is D1 in RORO and D7 in GEFI. And the questions were same. Now, if we look at these results, I've just done the frequency analysis of this. What we are seeing is around 23 participants have given answer as 45, node number 45, considering 45 has the highest degree amongst other personal nodes. And what you're seeing here, again, in GEFI also, same number of participants have chosen 45 as the answer. Now, we have to find out which platform is better in terms of giving the quality decisions. Now, in this case, 45 is the highest frequency. And what is this indicating? Highest frequency is indicating more participants have chosen the same answer, which indicates more stability. But not just this parameter we considered to check the quality of answers, we also considered variation, the number of possible answers that they have chosen. Now, if you see here, although 23 participants have chosen this as answer, but there are few participants who have chosen other answers as well, like node 20, 28, 60, 63. And here also you can see a big spread, number of nodes that they have chosen. So if you see this is 4 number of possible answers. And on GEFI, there are 6 possible answers that participants have chosen. But one thing which was, very striking to note was, we also compared these answers. Are there any, not non-logical answers that they have selected? I'll give you the example. Let's say for GEFI, the question was to select one of the influencers out of the 3 options. Now, if you see this, around 3 participants have chosen some wrong answers. Wrong in the sense they are non-logical. In the sense where they have chosen 11 and 39. Where 11 and 39 are influencer nodes. No, that was D4, by the way. And here in this question, we are talking about personal user. And they have chosen influencer node, which is completely logically incorrect answer. So if we see these 3 parameters to compare the quality of answers, for question number 1, we can say RO is producing higher quality response, at least for question number 1. And like this, we did the analysis for all 6 questions. This is question number 2. And again, on question number 2, the quality of answers in GEFI is higher than in RO. And we go back to the question that we considered, that was D4 and D10. What you're seeing here is again the spread, the highest frequency of answers, and I'll show you the results on the next slide. On RO, there were 6 possible answers which were chosen, and on GEFI, there were 5 possible nodes that were chosen as answers. Highest frequency on RO was 12, that is 12 participants chose a particular node as answer, and here it was 10. And logically wrong answers. So on RO, 6 participants chose incorrect answers or wrong answer, but they're logically incorrect. Why? They chose 22, 54, and 55. As you can see here, 22, 54, and 55. In this question, they were expected to choose the personal node, and these are influencer nodes. So that way, because logically wrong answer. And same here, 7 logically wrong answers. They have chosen 33 and 39, and 33 is a personal user where they're expected to answer some influencer node, but they have chosen personal node as the answer. So the quality in this particular question, again, the quality of answers in RO is higher than in GEFI. So we did like this analysis for all 6 questions, and I'm just not going through each of them, but here is the summary of all the 6 questions that you can see. For question number 1, it was RO. Question number 2, GEFI. 3 RO. 4 RO produced higher quality responses. 5 GEFI, and 6th again RO. So out of 6, 4 instances are where RO produced higher quality answers. So here's the conclusion. I just now said that here are the 4 instances with RO, and with GEFI we got 2 instances. Now, this suggests that RO may be more effective in facilitating high-quality decision-making compared to GEFI. However, the variation in responses indicate the platform effectiveness may be context-dependent, and also there may be some other factors which will also influence these platforms and the results or the responses on these platforms. So that was the conclusion, and thank you so much. And we are here for any comments, any feedback, or any questions that you may have. Thank you so much. Any questions, any comments? Yes.
In your research design, the assumption 3D VR is the assumption that 3D VR is more immersive than 2D platform, 2D environment, or 3D environment more immersive than 2D environment? What is the assumption?
In terms of immersiveness,
Immersiveness.
yeah, we do not consider the flat screen to the representation being immersive. And the reason is that you only have like frontal vision, but you don't have lateral vision. You don't have movement into the data space, which you can get with the headset. So in a way, it's just like if you were. Can you listen?
No, but
Yeah, I
for
guess.
purposes, I'm just saying.
Yeah, okay, but this is not the recording, but it's trying to explain.
And what are
The
participants?
recording is being done by this microphone. Yeah, so the question is, what is considered immersive or immersiveness in this case? And we consider that being in there, like when you are using a headset, a VR headset, that's for us the technology that allows us to reach this immersiveness stage. But when you use a flat screen, you are not, by that definition, in that situation. So it's more like, we call it like traditional or typical, or what has been done up until now. Yeah, that's the difference between the two.
Was there any effect on analysis of the cognitive load between the two fact forms, between the two environment? You said that cognitive load, according to the design of the question, was similar. That is what was kept in mind while designing the question. But what was the actual experience, your experience as readers of the participant? How was actually the cognitive load between the two environments?
Yeah, let me, if you have an answer, yeah, you're more than welcome. But let me just jump in here and say, the questions were designed in a way that we expect them to be harder to answer. And so we have the two sets. The first three are kind of easier than the other three. The story itself is longer, so that gives us an idea. Yeah, but also the fact that we do have this ambiguity already in the situation, where the solution is not going to be dictated by all of the centrality measurements being, or one of the centrality measurements being higher than the rest. So that ambiguity is already built in the situation being described for those higher, what we consider higher effort or higher cognitive effort. Now, in terms of what happened after, the first thing I can say is that the data we have that you saw on the slides is showing us some spread of answers, which is showing us between the low cognitive effort questions and the high cognitive effort questions that subjects, the volunteers' answers were more spread. So they were having a little bit more difficulties in judging by that. Now, we also ask questions that regarding the experience, what they felt or how they lived through the experiment. We have not analyzed that yet. So you have something to add?
Yes, continuing on what Fernando said, and to answer your question, Ajay, you asked about, okay, you designed the questions considering or expecting that comparable questions have similar cognitive effort or cognitive load required. And what we found in terms of cognitive load and what you're seeing here in terms of results is when you see this variation, now this is one of the high cognitive effort question. The spread, like Fernando said, is more in these kind of questions, last three questions versus the initial questions that you see. You see the spread here, number of possible answers, and also the number of logically incorrect answers. So when you are putting this lot of cognitive load while you are seeing the network and you are answering or you're coming to a decision, If participants have given some logically wrong answers, that means they are thinking too much and there is more cognitive load that they are experiencing. While this kind of logically wrong answers are fewer in lower cognitive effort questions, and they are higher on these higher cognitive effort questions.
So which VR is more cognitive loading to the participant?
Sorry?
The VR platform has a higher cognitive load because in the cognitive load,
Wrong answers that they have given on each. For example, for this one, the number of wrong answers on RORO are 5. Logically wrong answers are 5, and here on this particular question, there are 8. So considering all of these parameters, we have concluded that for this question, question number 3, RORO, the quality of answers in RORO is higher than GEFI, which may not be true for all answers. There are some answers or some questions where GEFI is performing better than RORO.
you cannot for sure say that the cognitive load on the users of VR is higher than on the 2D platform of GEFI.
The thing is that we're referring to the effort on answering the question.
Yeah, I understand that. I totally understand the design of the question is such. But what I'm contemplating is the real effect of the platform on two things. A, if it is cognitive load, then I feel that in VR, what I see here, it could be higher, whereas more immersive the platform should be, the load should be less, probably.
Yes.
But in this case, I would also like to understand how much time did the participant take to answer these questions on these platforms to be able to understand, okay, fine, they've given the answers, they've answered all the questions, that's fine. But if overall the time taken to answer these questions on the platform is higher on VR than on GEFI, which means that immersive visualization, people are actually immersed in VR or people are actually more immersed in GEFI. Because I would not, in my research, I would not feel that there is anything non-immersive. As long as it is interesting, as long as it is captivating the attention of the user to be able to answer that question, engaging the users to answer it, it should be immersive. So in that sense, GEFI is also immersive and VR is also immersive. But then the time taken to answer is talking about the quality, you're talking about decision quality. So I'm talking about quality in terms of speed, accuracy, efficiency, or efficacy.
Yeah.
Here we are only talking about decision quality in terms of correctness of decision, which is accurate decision. But how about efficacy?
We do have some data on the
Time taken.
on a subset, it's probably half of the where we measured the time, and I should have brought that result here because yeah, we had done that.
We have done that analysis of time
Let
required.
me just tell you a short story here is that we are still dealing with COVID times in a way. We started that first part of this research some time ago, and then because of so many issues happening over the last years, we had to stop. We ran out of funds, everything, and then we started to do it again. So we have actually two sets of data. We tried to maintain as much as we could the same conditions. I think we were successful at that. The version of the tool didn't change actually. No, fundamentally didn't change. So I would be confident that we kept the conditions, but the data was the time was recorded for a subset. And as long as I remember, there's encouraging results about the use of what we call immersive tool. Although I can see your point of using the term immersive, but following with the technology people called immersive or ROR, that was showing us that there was some advantage in terms of taking less time for the volunteers to reach a decision, to communicate an answer. I don't recall the numbers, like saying if it was 20% faster or whatever. I'll have to go back to the data. But I do recall that that was the general case for that part of the data. So it's an interesting point you're raising, and one that we need to be more aware of for the next round of experiments, which we will try to run sometime in the future.
One last point I have, sorry to ask so many questions. One last point I have in comparison for this particular data, how would you feel to compare 3D flat screen data with 3D VR data? In this, we see that you compare 2D data with the 3D data.
Yeah.
How about 3D flat screen data with 3D data on VR?
Definitely, I think it's something that should be done in the continuation of this kind of study. The reason why we didn't use a 3D visualization, network visualization tool is basically was the cost of acquiring the license. Because giving and other tools are free to use. So we decided to go that way. But there's, I think Neo4j has the facility to visualize that on a 3D representation on a flat screen, which sits in between the two somehow. And I think it's a good point to address. But no, we don't have at the moment.
I would love to extend this to 3D flat screen or 3D touch screen or even 3D holographics to see how in future of work, we're looking at the future of work with immersive analytics. The future of work with immersive analytics is moving towards 3D touch screen and 3D holographics, I think, more than 3D VR.
Yeah, so we do have we can at the moment do augmented reality, which is not that far from holographics, right?
Yeah, means there is a bit of a difference in representation or presentation of information, where it is like augmented reality is with the use of headset, and you see 3D visualization in that space. And in holographics, it would be like emerging out of the screen from the table itself. You don't have to wear any headsets or anything.
Yeah. Besides not having to wear the headset, the thing in front of you is more or less the same.
Yeah, it is more or less augmenting.
Yeah, the space, right? And you can walk, and you would have to walk around to be able to see that kind of thing, which is different from VR, what we have in VR. So yeah, all right. We can argue that we can also run. I mean, we can have some kind of, I would claim, close to holographic experience with our current technology, ROR.
Any more questions, Ed? Here on Zoom, any questions from anyone?
There's a question.
Oh, okay.
From Lisa.
I was just wondering whether you checked whether or not you had some participants making kind of logical errors in answering the questions. Did you look whether it was kind of the same participants making logical errors, and if it was potentially discarding them? I understand you're kind of already working with a small sample size and you might not want to reduce it further, but whether there's kind of an indication that some participants just aren't getting it and aren't understanding it, in which case they might not be adding anything to your data set anyway.
So we actually did that exercise.
Yeah.
When we saw that, there are participants who have made this logical mistake, we considered removing that data set. We did that data cleaning as well. But because I wanted to show here, and I'm yet to run the analysis on that clean data set, but because I wanted to highlight here the logical wrong answers, I have not presented those results, but we have actually done that kind of analysis and we have not removed the whole participant's data. So let's say a participant has answered incorrectly and logically incorrect answer, then only for that question we have removed the entry for that, instead of removing all 12 questions data for the same participant.
Okay. And just it looks like the questions you're including, like, can you explain your reason? Did anything interesting come out of that? Or?
Yes. So what you are seeing here, like for example, for question 1, I'll focus on question 1. Yeah. If you see here, the question 1 says, who is the most connected personal user and why? So we still have that data where they have given the reason of their decision, why they think node number 45 is the most connected personal user. Is it that they are considering degree? Is it they are considering closeness or betweenness? So we have the reasons behind their decisions. But again, because this is still work in progress, we are yet to analyze that data, but we have that data. So yeah, that's why you don't see a Y here in this analysis.
Had a question.
Thank you for a very enlightening presentation and, taking cue from the last question that Lisa just now asked, and because I work with a lot of unstructured data. So when they answered why, did they just mention that, based on what degree or what centrality they think that this would be the answer? Or did they write down their explanation? I mean, did they provide a textual answer to that?
Very good question. And I would like to say for these two platforms, the responses were different. And I'll tell you how. Because when they were working on their questions on Gephi, they were sitting in front of the computer, they had a pen and a paper, and they were writing their responses. At that time, most of the participants have given not just with centrality, because of with centrality measurement, they have given this decision, but they have added some, open-ended answers there. Now, on RO, the way we ran this experiment is because they are wearing this headset, they cannot read the question, right? So one of us were dictating the question to them and we were collecting their responses. So whatever they were saying that, okay, my answer is node number 45, we were noting it down for that particular participant. This is the answer to question number 1, for example, on RO. And wherever they were giving the reason of this answer, we noted down that. But I can see the richness of answers because they were writing on their own is better in Gephi rather than in RO. Because in RO, they are dictating and they are telling us what they think is the correct answer and why they think is the correct answer. So as much as information they are given, we have noted it down.
So did you analyze that textual part of the answer? I mean, the entropy or maybe.
Yeah, so that's a very good question. Yes, entropy, because we have again done.
It is a good question because we have 2 slides.
Yeah.
We were prepared for that.
Yeah.
So not just the quality of answers, and because these node numbers are not the continuous numeric values, we cannot calculate mean, median, standard deviation and all of that. First, we followed that path of, doing ANOVA or all of that kind of stuff because we have 2 groups, we have 2 platforms. But then we realized that no, these numbers are not numeric values, these are node numbers. And that's why to compare the platforms on consistency, we're exploring the Shannon entropy and also Gini index to understand the consistency of responses and whether responses are more stable or not. And we ran this analysis, and here are the results for entropy. Again, mixed results like we got with our analysis of quality of answers.
The lower the better, right?
The lower the better, both entropy and the lower the better, because lower entropy means higher consistency and lower Gini index means more consistency again. So lower value, the better. What you're seeing here, again, blue is RO and G is Gephi. And for question number 1, 2, RO is better. Again, for question 6, again, RO is better in terms of entropy. And if we calculate the Gini index, similar results. Question number 1, 2, 6. RO is better, and 3, 4, 5, almost 4. In this case, 4, it is equal. So both platforms are giving the same.
One last question from my side.
Yeah.
Because I'm just trying to, map from the very onset, like Fernando, you mentioned that you're looking at the comparison and see whether there is an improved decision making. So, and since you mentioned this is a work in progress, so based on the results that you have so far, would you answer that broad question at this point in time, or would you wait for more analysis? Because based on the final results that we've seen, where on 4 instances, RO had provided better results, performed better quality results as compared to Gephi.
We want to keep on that neutral side, that neutral paradigm, being an honest researcher. But there's a little bit of pollution here because we have this tool and we're very excited about using it and finding it. And I think bringing Ruby to the team has brought that thing that would help me get away from that excitement and get into into the using the lab and using the evidence and the data. And I have to say at the moment that I would not put my hand on the fire yet. But we have data that we haven't explored, and I'm hoping that that will give us what we want, because there's some richness associated with that data that we need to analyze still. And this last part that we just talked about, I find it quite interesting. We need to get a better understanding of those two measurements for a study. Okay, so
Any questions from here?
yes, I think we need to stop because.
Was there something in the chat though? I feel like I saw
Okay,
something.
that would be the last one.
Yeah.
If there's a question there.
Okay, there is a question.
Rational for using different sets of questions. Yeah, well, I can speak about that quickly, and they are not different. They are different questions in that the stories are different. Yeah, we may tell a participant, look, this is your boss. He wants to do this, and he has already decided this. Now you decide the next step. But the question asked in the other platform is different in that the story is different, but it's the same kind of question. It is asking for, the other question will be also asking for search for a node among these options. In that questions, they are not different. But we didn't want to have the exact question being asked in the two for most of the questions. Mainly because we don't want a repeat. We don't want the volunteers to basically do the same.
Sometimes they
same
remember
thing.
what was the answer for question number 3, and then
So we wanted to have a similar question, and same structure, different numbers, just like what you would ask in a test in any class, having the student prepare for that kind of question. That's probably the best I can say now. All right, now let's stop here. And thank you very much for your help and your attendance.
I'll end the meeting here. Thank you so much for joining us on Zoom. Thank you.